Alright, hopefully this is the last day we do this radical stuff. You're probably hoping it's the last day too, aren't you? Well, let's talk about this. Here's a phrase that we're going to use. It's called rationalizing. I don't think we did this yet, have we? Rationalizing. Rationalizing. Look in that word rationalizing. It's got the word rational. Basically, what's rational mean? It's a fraction, right? Okay, so we're rationalizing the denominator. All right, here's the deal. This is basically just a simplification thing. You're not really like solving for anything. You're not solving for x or solving for y. All you're doing is just simplifying a fraction. But in the fraction is a square root or any kind of root. It doesn't have to be a square root. It could be a cube root, fourth root, or anything else. By the way, somebody, I don't know who it was, but somebody actually watched one of my videos. I don't know who it was, but they found them. Somebody besides you guys. And they actually found a mistake that I made. And I did make a mistake. I think so, yeah. I don't know who it was. And they commented on my video and said that there was a mistake, and there was. But I went in and fixed it. It's got these little annotation things you can do on YouTube. You ever see anybody do that where they put a video out and they mess up and then you put the little pop-up things? So I figured out how to do that. So if you look at my very last video at the very end, if you just scroll to the very end, you'll see my correction. It was just a slip of the mind kind of thing. It wasn't like I didn't know what I was doing. It was supposed to be cube root instead of square root, and I kept it a square root. So you guys are at fault too, because you should have caught it. So I'll blame you. All right, enough of that. Here we go. Rationalize the denominator, which means what we're going to do is we're going to simplify the denominator. Let's just start off with something really simple. Okay, 1 over square root of 3. Now, for some reason, I'm not really sure why, I've researched it, and I don't know if I've come up with a real good explanation or not, but anyway, the powers that be, whoever that is, said that they don't want a square root or any radical in the denominator. Okay, you remember that from Algebra 2? Yeah, for some reason they say that this is not simplified. Even though, can I take the square root of 3? No, I can't simplify that. Even though it doesn't look like I can do anything with this, I don't want to have the square root in the denominator. Whoever made all this stuff up, right, said that we can't have that. So I'll just go with them. All right. And so what we have to do is we've got to change it so we don't have a square root in the denominator. Have we done this yet? We might have done this when we did the Saxon. I think we did this when we did the Saxon stuff. Okay, so we're starting from scratch now, all right? So look at this. What if I had this? I'm going to make up another number. This has nothing to do, this actual number has nothing to do with this, just the process is what I'm looking at. So what if I had the square root of 2? What if I took the square root of 2 and multiplied it by the square root of 2? What do I get? I just get a 2, right? Just a plain old 2, right? What if I took the square root of 17 times the square root of 17? What do I get? 17. You getting the pattern? Watch. What if I took the square root of 527 times the square root of 527? What's that equal to? 527, right? So basically, the square root of x times the square root of x would be equal to what? Just x. You agree? Now, that's pretty important, because if I have a square root, all I got to do is multiply it by itself, and guess what it does? Gets rid of the square root, right? You see that? All right, so what do I want to do? I want to get rid of the square root on the bottom, don't I? So what do you think I can do to it to get rid of the square root? That's right, multiply it by the square root of 3. Multiplying it by itself will get rid of that square root. And remember, I don't want a square root in the bottom, so I have to do something to get rid of it. I multiply it by itself. You with me? Okay. Now, I can't just multiply the bottom by the square root of 3 and expect this fraction to still be the same. All right, but if I multiply the bottom by the square root of 3, I can also multiply the top by the square root of 3. Now, a lot of people think it's the rule, whatever you do to the bottom, you do to the top. Well, that's not the rule. There is no rule. There is a rule in algebra that says whatever you do to the what? Left side, right, or to one side, you do to the other side. Okay, we're talking sides of equal signs. This is not that rule, is it? What did I just do? I did it in red because I wanted it to stand out to you. What's anything divided by itself? It's a 1. So really, all I'm doing is multiplying this by what? A 1. Does that change the value of anything if I multiply it by a 1? No, it doesn't. So But why did I do that? What was the purpose in that? Well, the purpose in that was to get rid of the square root on the bottom, right? So what's the square root of 3 times the square root of 3? I did all this for a reason. What's the square root of 3 times the square root of 3? It's just plain old 3. Okay? And now we can multiply the top. What's 1 times the square root of 3? It's just the square root of 3. So 1 divided by the square root of 3 is the same exact thing as the square root of 3 over 3. It's the same exact number. If you don't believe me, pull out the calculator and try it. Go ahead, Daniel. What's 1 divided by the square root of 3? You got the calculator sitting right there. 0.5 something. 0.5 what? Give me a couple more. 0.577. Okay. All right, so that's what that is. Now punch in this. Punch in the square root of 3 divided by 3. Same exact thing. All right. Now, of course, that keeps going. All right, but it's the same exact number, even to the last decimal place, right? It's exactly the same thing. All right. So would you agree that they're equal to each other? Yeah, absolutely. All right. That's called rationalizing the denominator. So if you take a college class next year and they'll say, "Do you remember rationalizing the denominator?" You'll say, "Sure, I do, Mr. Hammer. I'll show you the video." Right? That's what you should say. All right, so there you go. That's a real basic one. We're going to go a little more difficult than that, but that's pretty basic right there. You okay with that? All right. Let me find. I don't know. Let's just do another one. We'll just put instead of a 1, we'll put something up over top of this. I don't know, 7. I'm just making one up. All right, so if I ask you to simplify, and that's what it says to do on all these, we're not really solving for anything. All we're doing is simplifying. So what's wrong with this? Why is it not simplified right now? Square root on the bottom. That's right. So how do I get rid of that square root? Okay, multiply by square root of 7 on the bottom and on the top. And why do we do that? Because why do we multiply by something over itself? Because we're just multiplying by a 1. All right. So let's see what happens. Let's do the bottom first. Square root of 7 times square root of 7, just 7. All right, and this, is that the square root of 35? No, because that's a whole number 5. It's just 5 square root of 7. Does that 7 cancel out with that 7? No, it doesn't, because that's a square root of 7, and that's a plain whole number 7. They're not the same numbers. They don't just cancel out. And you just leave it like that. That's actually more simplified than this is. And you look at it and you're like, that doesn't look more simplified. There's 3 numbers here, and there's only 2 here. Why isn't this more simplified? Well, the powers that be, whoever that was, said that we need to get rid of the square root on the bottom. All right? And we did. We stuck it on top. But we don't just take it and throw it onto the top, do we? All right? You've got to realize you just can't take this and chuck it up to the top. Multiply the top and bottom by the square root of 7. You get 5 square root of 7 over 7. We good? All right. Now these were all square roots, weren't they? What if you had a cube root? What if you had like the cube root of 5? What would I have to multiply that by? What do you think? Do I just multiply it by another cube root of 5? Does that get rid of it? No. No, it's not square root of anything because it's a cube root. You can't just get rid of the cube. Because right now, what do I have? Basically, I have the cube root of 5 and 5, don't I? What do I need? I need one more 5 here, don't I? Because look, if I have 3 5s here, and that 5 cubed, and then the cube root of 5 cubed, do you see it? So the cube root will get rid of that cubed. But, so what do I have to do here? I got to multiply it by another cube root of 5. Do you see it? Alright, so in order to get rid of this cube root, I have to multiply it 2 more times to get a 5 cubed. You get it? So now, what's that going to be? What's the cube root of 5 times 5 times 5? It's basically this. Thank you. It's basically the cube root of what? 5 cubed. What does that cube root and that cube do to each other? They cancel each other out. So what am I left with? Just a 5. So if I have a cube root of something, I don't just multiply it by itself. I multiply it by itself 3 times, right? 1, 2, 3 of them. You see that? That'll get rid of it, and that'll become just a plain number 5. So if I have a cube root in the denominator, I don't just multiply it by itself. Okay, I got to do it 3 times. Does it make sense? Let me pause for a sec. All right, let's take a look at this. What I want to do, hey, we're up here, right? Okay, watch. What if I had 2 over the, we'll do cube root again, cube root of 7. All right, I'm just making this up off the top of my head. So what are we going to have to multiply it by in order to get rid of the cube root? We already have one of these cube roots, right? So how many more am I going to have? Well, 2 more, right? 3 altogether, right? Because I already got 1 here. I need 2 more. Would you agree with that? So I could go, whoops, cube root of 7, cube root of 7, couldn't I? All right. I don't want to do it like that, though. That's a little bit ugly. So what I'm going to do is this. I'm going to go cube root of 7, what? I need 2 of them, so 7 squared. Isn't that the same thing? Because that right there is the same thing as, watch, you don't have to write this part down, but watch, it's the same thing as the cube root of 7. It's the same thing as having those 2 7s under here. It's the same thing as having the cube root of 7, cube root of 7, isn't it? This is just a nice, prettier way to write it. So how many do I need altogether to get rid of that cube root? I need 3 altogether. I already got 1 here, don't I? So how many more do I need? I just need 2 more. Do you see that? So there's your cube root of 7. There's your cube root of 7 cubed. So really, what do I have now? I got the cube root of 7 cubed. Did I say cubed on this one? I meant squared. Cube root of 7, cube root of 7 squared. So if I multiply them together, it's the cube root. Watch. It's the cube root of 7 what? Cubed. What happens to that cube root and the cube? They cancel each other out. So what am I left with, basically? Just a 7 on the bottom. And that got rid of that cube root, didn't it? We'll do a couple more to get this. Now, if I do that to the bottom, what? I got to do the same thing to the top. So, oops, let's make that look like a 3. All right, cube root of 7 squared on the top. Okay? So, let's see what I get. What happens right here? See, that's a 7 to the first, that's 7 to the second, so that's 7 cubed. It's the cube root of 7 cubed, which is just 7. Now, what do I do to the top? I just write it like that. I write 2, and then I write cube root. Now, what's 7 squared? I could write it as 7 squared, but let's just write it as a regular number. What's 7 squared? It's just 49, isn't it? And then there is your answer. That's the same thing as that right there. Those are exactly the same. Let's do another one, okay? I know you probably want to see another one. Let's get rid of that. This. I'm going to keep that there just so that we can see. I'll tell you what, I'll even take this and move it up top here. Let's do another one. We'll just keep this for safekeeping just so that we can look back on it. Here's an example. This is a little bit different, but it's the same basic idea. We're going to throw something else in there, though. Let me make this a little bit taller, because I'm going to put a fraction under here. Now, this is a 4th root. It's a 4th root of 3/5. Well, what did we always do when we had a fraction? Split them up, didn't we? All right, so let's write it like this. Let's write it as one big fraction, but let's write, what, 4th root of 3, and then on the bottom, right, it's what? It's the 4th root of 5. See what I did? Because it's the 4th root of this whole thing, right? So I take the 4th root of this, put it on top, then I take the 4th root of 5, put that on the bottom. All right, I just split them up. We've done that before. All right, look back on the old videos. Remember this? If I had the square root of 3 over 2, how did I rewrite that? Square root of 3 over the square root of 2. It's the same thing. It's just the 4th root this time, not a square root. You okay with that? All right. Now, what are we going to have to do to the bottom? I already got 5 to the first, don't I? But what do I want? I want the fourth root of 5 to the fourth. Am I going to multiply it by the fourth root of 5 to the fourth, though? No, I've already got one of them, right? So, right, I need a 5 cubed, exactly right. Because look, I already got a 5 to the first. If I multiply it by 5 cubed, that'll be 5 to the fourth. I want to get 5 to the fourth, don't I? Because the fourth root of 5 to the fourth, the root and the fourth will cancel out. Does that make sense? So it's always one less than what this is. Right? You get it? Because look, this is 5 to the first. That's supposed to be a 1 right there. It's 5 to the first. I want to get it. How do I know what exponent I want to get it to? I look what that root is. If that's a fourth root, I want this to be 5 to the fourth. Right? If it was a third root, I want it 5 to the third. If it was a seventh root, I want it 5 to the what? Seventh. Well, I've already got a 5 to the first here. What do I have to multiply it by? 5 to the third. You see it? Now that'll give me 5 to the fourth. When I multiply them together, that'll cancel out my fourth root and my 5 to the fourth. So we do the same thing to the top. So it's a fourth root of 5 cubed. Does that make sense? This is probably something you didn't do in Algebra 2. This is what college algebra is, just like a little step above. It's the same principles that you learned in Algebra 2. We're just taking it a little step higher than what you probably did in Algebra 2. Now, let's see what we got on the bottom. What does this happen to be? Now, you don't have to write this down, but I just want you to see what this is going to be. This is going to be what? 5 to the fourth inside of there, isn't it? Because that's 5 to the first, and that's 5 cubed. So, right, because that fourth root of 5 to the fourth, the root and the fourth cancel out, so that's just going to be a plain old 5. But now, what do we do to the top? Got to multiply these together. Now, this is all under 1/4 root, isn't it? So it's a fourth root, but what do I have under there? I got a 3, and I have what else? 5 cubed. See what I did there? Multiply them together, and I can multiply them together because that's a fourth root and that's a fourth root. So I can multiply them together. What do? I just multiply these two together right there. Somebody do that on a calculator for me. What's 5 cubed? 5 times 5 times 5 is 125. And then 125 times 3 is 375. Right? So what do? We just write the fourth root of 375. And that whole thing is over what? 5. And there you go. That's it. That and that is exactly the same thing. If you want to punch that in your calculator just to see, feel free to do that. That's a good way to check. Right? Now look, just putting this into a calculator and getting a decimal number, is that the kind of answer I'm looking for? Will I give it to you on a quiz or a test? Absolutely not. Right? This is simplest form right here, not a decimal approximation. Right? So you could use your calculator to check to see if this and this come out to the same decimal. That would be fine. I would suggest you do that. Okay, but you got to go through this process and get that as your final answer. I want this. Okay, multiply that stuff together. You got a calculator. It doesn't take too long. All right, so multiply those together and give me an answer underneath it there. Everybody got it? Okay. Okay, we're going to do one more, rationalizing the denominator. But on those other ones, I'm just making this up, the denominator was just a monomial. All right, it was just one term. There wasn't anything being added or subtracted, was there? There was just a monomial. It was pretty easy to do. But what if you had something like this? What if you had 3 over 2 plus the square root of 5? That's a little bit different. Okay? There's a little bit of a different process. You can't just multiply the bottom by the square root of 5 and expect the square root of 5 just to go away. Because if I multiplied the bottom by the square root of 5, I'd also have to multiply what? The 2, right? So watch. 2 times the square root of 5 is 2 square root of 5. Square root of 5 times 5 is just 5, but I still have a square root on the bottom, don't I? So that didn't help me get rid of that. It got rid of this square root, but guess what it did? It made another square root. Does that make sense? Because I have to distribute it through here. I would get 2 square root of 5 plus 5. That didn't get rid of the square root, and that's the whole idea. I have to get rid of the square root on the bottom. That's not going to work. I want to show you something here real quick. What if I did this and I multiplied it by itself? Let's see what happens. Oops, I'm sorry, not by itself. But it almost is by itself, but one's positive, one's negative. You remember that difference of two squares stuff we did? That's kind of like that. So let's see. What happens if I take this binomial, multiply it by another binomial? It looks exactly the same, except what'd you just do? You just changed what? The sign in the middle. That's right. Let's see what happens to this, just for fun. All right? Distribute, right? Okay, so square root of 3 times square root of 3 is 3. Now watch. This is the same thing as difference of two squares, so what do you think is going to happen? This is negative 2 square root of 3 plus 2 square root of 3, which just does what? Goes out to 0. That's right, it adds up to 0. So I don't even have to worry about doing that, do I? So I just do the last. Now, what's 2 times negative 2? Negative 4. What's that equal? Negative 1. Guess what we did? We got rid of that square root, didn't we? So if I take something like this, multiply it by itself, but just change the sign in the middle, then that'll actually get rid of your square root. You could try that with any combination of numbers if you wanted to. All right, that'll get rid of your square root. That's pretty cool, isn't it? Nice little thing to do. By the way, we give this a name. We call it the conjugate. Write that down. All right, so if I had something like this, if I had 2 plus the square root of 7, what would the conjugate be of 2 plus the square root of 7? 2 minus the square root of 7, exactly right. If I multiplied those together, that would get rid of the square root. You see that? All right. So, with that said, that's all we got to know. Let's do an example and we'll see what happens. Okay, remember they're called conjugates of each other. This is a conjugate of this, or this is a conjugate of that. If I started off with a 2 minus square root of 7, what would the conjugate of that be? 2 plus the square root of 7. All right? So I could start off with a minus as well. And in fact, this example, they actually do. Start with a minus. 1 minus the square root of 2. I want to simplify this. That's what all these problems say to do. Alright, we're going to simplify. I can't just multiply by the square root of 2 because I'd have to distribute it through here and I'd still have a square root of 2. Alright, so I've got to multiply it by something else. And so if it's a sum or a difference like this, how do I get rid of that square root? Multiply by its what? Conjugate. So what's the conjugate of 1 minus the square root of 2? 1 plus the square root of 2. Good. Now we multiply those together. Now in order to show the multiplication, I put those in parentheses. Now watch this. If I do that on the bottom, guess what? Got to go to the top. Right, same process as what we talked about. So 1 plus the square root of 2 on the top. We'll put that in parentheses. Now I don't do that just because whatever I do to the bottom, I do to the top. I do that because what is that whole thing right there? It's a 1, isn't it? So really all I'm doing is multiplying this fraction by a 1. Does it change the value of it? No, it doesn't. So it just changed what it looks like. It doesn't change the actual value of it. So let's multiply these two together. And the multiplication is pretty easy. It looks like a FOIL method, but really the outside and inside add up to 0, don't they? So really all I got to do is multiply the first and then multiply the last. So watch, the first, 1 times 1 is 1. Negative times positive is negative. Square root of 2 times square root of 2 is just a 2. Look at that. Pretty easy, isn't it? Alright, just multiply the first and the last. Look at the top. It's just 1 times this, so what do I get? 1 plus the square root of 2. Now I got to simplify this. What's 1 minus 2? It's negative 1, isn't it? Now what they do on this one, everything's being divided by a negative 1. So what's 1 divided by negative 1? It's negative 1. Okay? What's square root of 2 divided by negative 1? It's positive square root of 2 divided by a negative 1. It's negative what? Square root of 2. And that's how they want you to write the answer like that. You see it? Alright, so if there's a negative here, it's 1 divided by negative 1, which is negative 1. Then it's positive square root of 2 divided by negative 1, which is negative square root of 2. You good? Alright. I think we've covered everything on 1-7. Took 2 years to do it, didn't we? last year and this year. But that's the process. Jacob?
Are you gonna have functions with variables?
These will, don't know. Probably could. Sure. Yeah, you could. Yep, you could have these with variables in them. But that wouldn't be hard. Because watch, let's just change it up. What if I said 1 plus the square root of x? How would I, and that was a denominator. We'll put an x up here. What if I wanted to simplify that? Right, so it's just 1 minus the square root of x. Then do it to the top, 1 minus square root of x. So remember, the outside and inside add up to 0, which is nice. So it's what? 1 times 1, which is 1, minus what? Square root of x times square root of x? It's just x. And then what's the top? It's x times this, isn't it? So I would distribute it through, wouldn't you? This and this. So what do we get? X minus x square root of x. And that would be your answer right there. I guess if you wanted to, you could leave it like this. It probably wouldn't be any different. The top, right? And then this would be 1 minus x. That would be fine too. I wouldn't care either way. But sure, you could put variables in there and still do it the same exact way. Just wouldn't simplify quite as far as what this did. All right, I think that should cover it. Now, I'll warn you on some of these problems on the worksheet are exactly like what we did. And there's a couple on here, just a couple on here that are a little bit trickier. All right, so you have to think a little bit. Go back to the video, go back to your notes. All right, if you have a problem on how to do one of these, you don't have to sit here for 27 minutes and watch the whole thing from beginning to end. All right, just scrub through, right, until you get to the part where you didn't understand, and then you can just watch that part of it. All right, so 1.7b is what I'm going to give you today.